Hi, this is John, and welcome to another edition of Statistics Tell a Story. So I wanted to go over some probabilities and the way that they're arrived at. I had mentioned this a few episodes back. They are, when you give probabilities or create probabilities with these games, they're educated guesses. I want to give you a few ways in which I arrive at these, and I know that they're pretty similar, with other mathematicians who are inclined to predict football games. So let's look at a trend this past week, actually, that did apply. The Steelers, going into the week, were 56-25 as a single-digit underdog under Mike Tomlin. Okay, pretty strong trend, seemingly, and it actually worked against the Rams. They were a 3-point underdog, and they ended up not only covering but winning. Okay. But let's delve a little bit into this. There are a couple parameters here. One is that they're an underdog. Another is that they're single digit. And the point is, the more that you have to filter something, the weaker it becomes. For example, we could try to find a trend that, we go back in our history of football, and we find, we might find some weird trend that works 70% of the time, where a team covered after traveling from the east to the west, and the national anthem was over a minute long, and it rained 2 days before, and so forth. And you look at all these filters. Well, if you look at enough filters, you're bound to find something. Okay, so it kind of weakens it. So we kind of want to delve into some common sense with some of these, right? Now, this is only two filters, two parameters. I'm calling a filter a parameter, so that's not so bad. We might also look a little bit into it. Again, we're taking some educated guesses, and we're even taking educated guesses on Mike Tomlin. Do we think that something like that will hold up? Well, you look at Mike Tomlin, and you look at his press conferences, you read in the paper, and I'm from Western PA, so I get to see him maybe more than some others, but he seems like, what you might call a player's coach, and he seems like he brings out the best in players, and maybe in particular when they're an underdog. So there's a good chance this has some credence. Now, how much strength is in that? Which is a big question. If we were to play this out many, many years, which of course we can't, because Mike Tomlin, like all of us, he's going to get older, and he's going to get out of coaching football. But let's pretend that we can go on forever and ever, and we can have a huge sample size under this condition. 56-25 is probably not going to hold up. It's something in the ballpark of 70+%, and that's just too hard to expect. But what might hold up? Or what might we expect in the long run? Okay. There are a couple ways we'll look at that. Before we get to that, I want to go over an example of, there's actually three types of probability. One is called relative frequency. A basic example of relative frequency is, let's say you go to the bus, and you take the bus maybe every day for a year, right? You go to work, and so 250 days. And maybe it's the same bus driver every time, just to make things simple. And the bus driver is late 10 times out of 250 times. So you try to make a prediction of the next year, how often is the bus driver going to be late? Well, 10 out of 250, or actually 1 out of 25, is a pretty good guess, because that's probably going to remain pretty constant, unless there were some fluky things that happened that adjusted that one way or another. And when we do that, we are using relative frequency, meaning, well, the frequency prior to that was 10 out of 250, and so using that relative frequency, that's our best guess going forward. Now, we might say, why doesn't this qualify under relative frequency? In a way it does, in a way it doesn't. We certainly looked at the same type of thing. Out of 81 possibilities, 56 times they covered. The problem, again, with this, as opposed to the bus driver, is that we did a little bit of cherry picking, so to speak. So we were able to look at, like I said, all these possibilities, and we came up with that. And of course, there are other things that might involve, right? the bookmakers may start building things into the line. For example, they may have underestimated Mike Tomlin early in his career, and he padded a pretty good mark. So so there are some nuances that make, yes, relative frequency, but you don't want to put as much credence in it. Okay, so let's assume in those 81 games, the Steelers covered by an average of 4 points, okay? And let's assume that maybe even in the game with the Steelers and the Rams, they were a 3-point underdog, and let's assume the model, a good model, predicted they should be a 3-point underdog, okay? So model-wise, they'd have a 50% chance of covering, right? Because the model, we believe, is spot on. And again, the model is just the fundamentals that I talked about before, not the trends, which are a technical indicator, right? So the model says they are 50% chance of covering. Now we want to bring in this trend, okay? So they covered by an average of 4 points in those games. And again, it's probably overstating things. I've said this a lot, but I got to say it again. We're taking an educated guess. To some extent, it's kind of like, you may see a rookie ball player, right? He hits 320 in his first month. It's probably not going to hold up. There's something called Bayes' theorem that I've talked about in other episodes that kind of lend itself to it. But the fact is, this 4 points is probably on the high end. So, but we think there's some credence. So we say, well, let's assume that on average they're going to cover by, that trend is going to mean 3 points, right? Okay, so the model we said originally said they should be a 3-point underdog, and they are a 3-point underdog, but we're going to say this trend is worth 3 points, which now makes them even with the Rams, right? Model says 3-point underdog. We're taking 3 points for the trend. That means it should be 0. All right. So they're getting 3 points when it really should be 0. How can we attach a probability to that? There are a couple ways we could do that. One is we could look at our database of all pick'em games or virtual pick'em games. If something was a -1 or +1, we might put that just to create a bigger sample size. But let's assume pick'em games, right? And let's just say we have 500 games in our database going back many years, and there are 500 pick'em games. And we see that again, it's really not a pick'em game, but we're assuming it is a pick'em game. Well, of those pick'em games, which we're saying this should be, how many times did a particular team cover if getting 3 points, which is what the Steelers are getting? Maybe that's 57% of the time, okay? So that's one way to say, okay, if we look back, when you're kind of given a gift of 3 points, so to speak, they're going to cover 57% of the time, so we might take an educated guess. Steelers are going to cover 57% of the time. There's another way to do it, which is a little bit more theoretical, you might say, and it's based on the normal distribution. Again, we're fudging a little bit. Number one, football scores probably don't quite follow a normal distribution, and that's a whole other episode, but they're probably reasonably close, okay? Now, many of you might be familiar with a common example with IQs, right? The average IQ is 100. Standard deviation is 15. So if a person has an IQ of, say, 115, that means they're one standard deviation above the mean, and we can find a probability attached to that. The probability that any given person, right, you see walking down the street, has an IQ of 115 or more. The way you would do it is you would find the corresponding area under the normal distribution curve. We can kind of do that here. What do I mean by that? Okay, hopefully you can see this little chart. Sorry, I'm hurting for space here, but let's say we look back at all pick'em games and we see that the end result, right, the difference in the scores has a standard deviation of 12, okay? The formula for creating what's called a z-score, okay, is equal to the value you're looking at. In the IQ case, it was 115, minus the mean. In the IQ case, it's 100, over the standard deviation. In the IQ case, it is 15, right? I don't have that written here, but it would be 115 minus 100 over 15, which is equal to 1. So you know it's one standard deviation away from the mean. You look at a particular chart for the normal distribution and you find the area. Same type of thing here, only we're dealing with these averages. The S we assumed was 12, and I just kind of picked that out of thin air just to make this example kind of a little bit clean. The mean is 0, meaning the expected difference is 0, and the X value, we would call it, or the boundary, much like the 115 in the IQ, is -3. We could also do it with a +3 because the area would be the same. If you have any questions also, please put it in the comments. I'm kind of glossing over this a little bit, assuming you might know a little bit with z-scores if you've taken a basic statistics course. If you haven't, again, I'm summarizing it right now. It is, you find a particular point on the normal chart, and it's in words, the boundary, which is -3, or 3 we could use, minus the mean, which is 0, over 12. So that's right here. Okay, this is actually the mean, which is 0, because we assumed a pick'em game. Okay, what do we get? -3 minus 0 is -3, divided by 12 is -0.25. That means that this particular z value is -0.25. Okay, we can find the area corresponding to -0.25. Now, in the Steelers' case, we would say that they're covering if they are from -3 to positive infinity, which means they're going to cover for this whole area here. Okay? What is that area? Well, this is 50% because 50% is to the right of the curve, 50% is to the left of the curve. What is this area? We would find the area corresponding to a z value of 0.25, because it's the same, -0.25 or 0.25 on a chart, right? You can find that. And you would see that area, I believe, is pretty close to 10%. So that would, in this illustration, gives the Steelers a 60% chance of covering. 10% here, 50% here, 10 plus 50 is 60%. The one hand, the way I did it, it was 57%. This hand, it's 60%. This is probably overstating a little bit. This might also either. It's probably somewhere, but the essence of it is 3 points, in this case, is probably somewhere between a 55 and a 60% proposition, right? I might very well call it 57.5%, 57%, something like that. One other important thing is, again, I just kind of did this in a quick fashion. There are some other nuances. For example, let's just say a team is a big favorite, right? You usually don't see it in the pros. Let's just say college, and they're a 30-point favorite. Well, what's the difference of 3 points when you're a 30-point favorite? Not near as much. And just to take a guess, an educated guess, right? If somebody's a 30-point favorite and they should be a 33-point favorite, and you're betting the favorite, they probably don't have a 57 or 58% chance of covering. Because the numbers are so big and there's more volatility, my guess is they might be a 52 or 53% probability, and we would see that borne out if we did something like this, okay? So, again, this is just kind of a quick summary to give some ballpark probabilities. I don't really just plug them out of thin air. I do use a little bit of intuition, a little bit of common sense. You know, models are imperfect, trends are imperfect, but that is how I arrive at it. Again, feel free to ask any questions. Hopefully I didn't ramble on too fast, but I didn't want to bog you down with details. So I appreciate you tuning in. Don't forget to hit like and subscribe, and I will see you next time on Statistics Tell a Story. Thank you.